Welcome guys. Welcome guys in the continuous sequence of the signals in the digital signal processing. So guys, in this video lecture we will discuss the rectangular pulse signal in the DSP. So guys, before starting the video I want to tell you, please subscribe my channel, like the videos, and if you have any query regarding this, please write in the comment section. So let's start the video. So guys, what is rectangular pulse signal? So basically rectangular pulse signal is a signal, or simply we can say a rectangle is divided on the y-axis. Here this is the y-axis, as you can see in this is figure 1, rectangle which have the unit amplitude, and the width of this rectangle is also 1 here, and has unit amplitude. So this is the rectangular pulse on the y-axis, and on the x-axis at the t duration. So it has a 1 is the width of this rectangle. So 1 is divided in the both side of the y-axis. So here the minus here 1 by 2 is divided in the both for when the value of this t is less than 0 and when the value of t is greater than 0. For both the conditions, this 1 width is divided on the y-axis for this rectangle. So this rectangle is divided in both the sides. Minus 1 by 2 is considered as the negative values, and 1 by 2 is considered for the positive. So when the value of this t is less than 0, this minus 1 by 2 is considered, means this half rectangular part is considered, and when the value of this t is greater than 0, and at that particular time this part is considered. So this part is considered. So here in case of the when the width of this rectangle is 1. So in the figure 2nd, here the width of this rectangle is as t is considered as capital T. So the amplitude of this second rectangle, that is A, is considered, and here this width is divided into of the same amplitude A and divided into the two parts on the y-axis, this, and here the t is divided in the two parts, that is minus t by 2 and plus t by 2, same as this previous case. And here this minus t by 2 condition is considered when the values of this small t are on the x-axis, that is less than 0, and this right path of this rectangle is considered when the values of this small t is greater than 0. So this is the second condition for when the amplitude of this rectangular pulse is considered as A. So both the cases we will discuss here below section. So first we will discuss the rectangle with unit amplitude and unit time duration. So here the x of t is the signal. So we represents this rectangular pulse signal with rect, R-E-C-T, rect of t. So here x of t is the signal, that is equal to the rect of t, rectangular pulse, that is equal to. So when the rectangular pulse signal is obtained 1, so at that particular time condition, so the value of this small t, or small t is in between minus 1 by 2 less than t less than 1 by 2. So here when the value of this t is less than 0, then 1 by 2 for unit width, this is the width of this one is the width here, unit 1, so 0 otherwise. So here let's understand this. For this, when we when we get this one values or for the one width of this rectangular signal, so the value of this t is in between the two values, half values of this width, so 1 by 2, minus 1 by 2 and 1 by 2, otherwise 0. So this is the rectangle with unit amplitude, and when the width of this rectangular pulse is also considered as unit. So let's move the second condition. Rectangle with a amplitude is considered and time duration is considered as capital T, we can simply say the width of this is rectangular pulse is considered as capital T. So here in the second figure, this one is the capital T is the width of this rectangle, whole rectangle. So here rect of capital T, that is for second. So here the amplitude is considered as, here in the previous case the amplitude is equal to 1, and in this second case the amplitude is a. The amplitude of the rectangle is a. Here the amplitude of rectangle is 1. So we get the signal for the second rectangle with the amplitude a. So at that particular condition, we get the a amplitude for the value of t is divided in the two parts, minus t by 2 to small t and plus t by 2 0 otherwise. So here also this condition is considered when the amplitude of a. So we get the for find out the amplitude of a. Here one thing more, this t, this small t is divided by this capital T. Here this t is divided by this capital T, so we can write here this small t, this small t, this small t, this small t is divided on this capital T with this capital T. So we can write here the rectangle of this small t is divided by capital T. So in the width, and here at that particular condition we get the signal, that is a, we get the a amplitude when this small t is divided in the two parts, minus capital T by 2 to plus capital T by 2 and otherwise 0. So this is for the second condition of rectangular pulse of amplitude a. So in the next, in these expressions, with the help of these mathematical expressions, here the capital T represents the function of time, and also for width, of this rectangle pulse. So a is the amplitude and rectangular pulse is the even or symmetric function. This rectangle pulse is even or symmetric function. So if I ask you what is the odd or antisymmetric function, so in the previous video, if you see the previous video, then I think you know the signum function, that is the odd or antisymmetric function, and this rectangular pulse is the even or symmetric function. So for find out the value of x of t, so here x of t is the signal of rectangular pulse, that is the a time amplitude of rectangular pulse, that is divided by small t to capital T. So this is the main formula for this rectangle pulse signal. So here we can consider this small t as the variable in the time t. variable in t times, or time duration t, and capital T is the total width of this pulse. Capital T is the total width of pulse or rectangular pulse. A is the amplitude of rectangular pulse, or ECT represents the rectangular signal. So for the possible frequency, to represent the possible rectangular signal frequency domain, so the formula for that, formula for representing the rectangular signal in frequency domain, frequency domain. So simply we can denote this x of f with this t. So t2, we convert this t to f, so that will be equal to, with a amplitude of this rectangular signal, and this t will be converted to f. Why t? So t is the combination of this small t, so here this will the 2 times f, so or simply 2 times fm we can here. So I will let I understand, let you understand this, how this fm here is considered. So if you can here, this is the figure of this is the rectangular pulse. Here this is here the 0, and here this is the fm. I consider this is fm, plus and minus. So here x of f signal, and this is the width of this this is the width of this rectangular pulse. So the width is capital, so the combination of these fm and fm, so here the 2 times fm, this is the width of this rectangular pulse. So here if fm is the modulate frequency, or we can represent this f plus fm and minus fm. So the combination of these plus fm and minus fm, that is the total width of this rectangular pulse. So a is the amplitude of this rectangular pulse. So according to this figure, so here we have find out this expression for frequency domain rectangular pulse signal. So here x of t, this f is the signal for frequency signal, and this fm and fm 2 times fm, this is the width or rectangular width. This is the, we can say the duration, and this is the amplitude, and this RECT is the rectangular, it represents the rectangular pulse, and x of f is the signal frequency in the rectangular signal in the frequency domain. This one is in the frequency domain, signal of rectangular pulse. So I think guys you get this idea about the rectangular pulse signal in the digital signal processing. So that's all for this video guys. So guys, if you have any query regarding this video, please write in the comment section and like the video, subscribe my channel. So thank you guys.